Hi everyone, good morning. Welcome to the session. Welcome everyone. A very warm greetings from Mercy Technologies. What is our agenda today? What we are trying to learn today? Our agenda for today is we'll be learning what are the types of data structures, what is asymptotic notation, and how to calculate time complexity of simple loops. This is a 3-point agenda, guys. This is what we are trying to see in today's session. But before I start, yesterday I got messages from few people asking me to share the details of the course and all. So I thought this would be the correct time for me to explain you what we are trying to do as part of this session. So my name is Surya. I have 8+ years IT industry experience. I'm working in a product-based company. I completely take care of 2 products. An important point, I often take on data structures, Java, and other related fields. So till now, guys, I remember I took more than 200 interviews to people across all levels. So be it freshers or for the experienced people. And one more important point is I am last 3 years. So I'm teaching for last 3 years. So this is my rough or simple introduction. So what are we trying to do as part of this course? This is something that people ask me. So let me introduce the course to you. What are we trying to do as part of this course? Okay. First, very important point is I will be teaching from basic to advanced. So we will be starting slow. But as we move forward, you'll be going into the advanced part. So I will see. So I'll be teaching you the things in depth. So it's not just learning the course, learning the concept. It's not like that. You need to be using it practically, right? I'll be teaching you the course in depth. So all the from this course from so practical to theory. So since I'm working professional, I'll make sure that you will be getting the course delivered in a practical to theory basis. It's not that I teach you theory and you practice. It's not like that. So we'll be dealing about the practical things that are happening in the industry now. And so I'll be teaching you using that practical. I'll be teaching you in a theoretical way. So the concepts would be, all concepts would be covered. So for example, let's say somebody asks in an interview, like, so find the length of a linked list, right? So this is a simple question. There may be n number of ways for you to analyze or give the solution to an interviewer. So what you say and how the interviewer gets impressed, right? It's all depends on impressing the interviewer, guys. So there might be different approaches, a single pointer approach, two pointer approach. So for the same question, what are the different ways we can move forward in it? And once we answer the question, how we can improve its efficiency, etc., etc. So every question has different ways to do, guys, and we'll be seeing different ways of solving interview questions in data structures. So as I said, I am a real-time guy. So I'll whenever possible. So whenever possible, I'll be giving you real-time examples as well. Okay. So till now, this is the introduction of the course, introduction of the instructor. Now let's see what you can expect from this course. What you can expect from this course. Let me write it down. First important thing that you can expect from this course is, after the course completes, so I claim this, guys, after you complete this course, you become an expert in data structure. You become an expert in. So what you can expect from this course, after you complete this course, you become an expert in data structures. And there are companies like Amazon. So I'm naming the big companies, guys, but there are product companies which ask you content or the questions on data structures. So Amazon or Google, etc., these kind of companies have will be having rounds on data structures. Not just these, any product companies will make sure that they have a round in data structures. So you'd be very comfortable in such cases. Okay. And one more thing that you can expect from this course is, as you grow in IT career, you can use these concepts and move further in your career. Okay, what I mean to say is, today I'm able to take care of 2 to 3 products. The reason is I have good knowledge or the good foundation on this data structures. So people tend to see what exactly you possess, what exactly you're bringing to the company. So not just for this course or not just for cracking the interviews, this course will help you to grow as a better programmer as you move further in your career, right? uh, so one more thing that I want to say is, like, many companies, as a first round, what they give is they give you some links to answer the questions. So like HackerRank. So this HackerRank is a test. They give that to you as the first round of interview. They send that a link to you in your mail, and you need to give that test. And after you clear that test, you'd be called for the interview in most of project-based companies. So what we'll be doing as we move forward in the data structures that we are learning, as we move forward after the course completes, or after course completes to a particular point, I'll make that you will be comfortable in answering the HackerRank tests as well. And one more thing you can expect is, so there will be exams. There'll be exams. Okay, you need to answer those exams, and after that you can be even more having better feedback. You'll be having exams as well. So after you complete linked list course, I'll be giving you a few HackerRank links so that you can master how do you solve those questions in HackerRank and HackerEarth. At the same time, So as the course moves forward, so you will be given a few exams, right? So a linked list exam, stack exam, tree exam, kind of, so that using all this, so at one particular point you'd be feeling more comfortable and you will be in a position to answer these questions in a better way, in a better way. So what I can expect from you, there is one more thing, right? It's not that you expect from me, there is one more thing that I expect from you as well, right? So I expect the below things from you. So after you join this course, I expect, so you guys should be regular, you should be attending the classes every day. So this is one very important thing for you to learn better. Okay. Uh, so what I say is you can attend few classes, and if you free good, you can pay and join. Okay, you can pay and join. And one more important thing is you should make sure you are attending regularly. So if you miss something, in case you miss something, everyone has a tendency or some reasons to miss. So you should go recordings. So so it's good that you follow the same daily practice, guys, because if you feel the flow, if you miss the flow, then you'll be missing something. So one more thing I expect from you guys is you need to start watching the recordings in the same day. Like if you want to be more comfortable, go through the recording one more time. Okay. One more, and what you call, you need to practice every day. One more thing is after doing all this, practice makes very important vital role. So you have to practice every day. So these are the things that I expect from you guys. I expect from you, because and you should be attentive. You should be listening to the class in an attentive way. Okay. So after this, you have got the gist or overview on what we are trying to achieve in this course. Uh, so let me clear one or two more doubts from students, guys. Who is this course for? Who should make use of this course? Who are the For whom is this course intended? Okay, so I'll explain that to you now. So for freshers, how for freshers this course is important? Because they might be in, they have just completed their course or they just came out of their colleges. So this course will make sure that they get a good foundation and they'll be able to answer the hacker rank test. They'll be able to go and attend big companies interviews. So for freshers, this is very important. And as part of second one, for experienced. So for experienced people, how is it important? I see people who are coming from service-based companies, they tend to, crack the product-based interviews. So for the people who are in that bracket, so they attend this course, then they'll be in a position to crack the product-based companies. So as you guys know, product-based companies pay more than service-based companies by more than a fraction. So for this, you need to have data structures and algorithms knowledge, because there'll be dedicated rounds, and only when you clear those, they might be the first or the second round. Only when you clear those, then they'll be coming to your technical. Do you know Java? Do you know database? Do you know Spring? So all this, they'll be coming after you clear this round, right? This is the barrier. Okay, you need to clear this round. So in that way, it is useful for the freshers as well. And there are one more category, college students. So there are college students who are doing the third year or fourth year of their BTech, or they are in the final year of their masters. So for these college students, these are blessed people, guys, because if people do this course at that time, then from then onwards they'll be having this rich set of knowledge, and they can move forward, and they can start their career in a better way than their peers. At the end, guys, what are the course details? So what are the course details? So this yesterday people asked me how long does this course go, or how much time it will take for the course to complete. So duration is 2 months. So, or we'll be nearly covering 50 hours. So we'll be nearly covering 50 hours of this session. Okay. And when? So the course starts at 8:30 in morning to 9:30. 8:30 a.m. to 9:30 a.m. and this is Indian Standard Time, guys. So what about the people who are attending from different countries? I have interacted with people who ping me from Africa and who ping me from America. So there people are attending from different regions in the world. So for those people who are not available on this particular live session, they will be given the recordings. But as I expect from you, you should be completing the recordings on that day itself, because only when you do that you'll be ready for the exams. And one particular time I announce an exam, and at that time you would be in the same page that all the Indian students are, right? uh, so this is so even the time is not suitable for you, yes, we are ready to give you the recordings. Okay. uh, One more important thing people have asked. we we are a set of software engineers, guys. We started up Mercy Technologies to share our knowledge. So as part of this, we have started this course. We found out that there are people who are lacking in few things while they go for interview. They may be expert in Java, they may be expert in database, they may be expert in Spring, but few product based companies not just expect all these, but they are expecting the knowledge on data structures and algorithms. By taking this an advantage, there are people who are charging too much for this course. Okay, what we have decided as part of Mercy Technologies is we will not be charging in a very high way, but we will be charging in a very reasonable way. So anyone who wants to know the fee details, guys, you can ping us in the WhatsApp group, or with a WhatsApp number. The below is our contact number. The contact number is 79758 55775. So anyone who wants to know the fee details or any more details, so you can ping us personally, right? So this is the introduction of the course. I have introduced you about me. I have introduced the course to you. I told you what you can expect from this course. I told you what I expect from you guys when you join, and who is this course for, and the course details. So one last point to add here, guys, we are not like other institutes where they give you some theory, they give you some material, and you need to learn. Even if you get a job or not, even if you learn it or not, they really don't care about you. But here, once you pay and once you join, we will take care of you like you are our kids kind. We will be giving you as much information as much possible, and whenever if there are offerings in some product based companies, and if there are some interview calls going on, if you need referrals, so we'll make sure that we will be guiding you in a proper way. It's not that you pay the fees and we leave you. It's not like that. We'll be mentoring you, we'll be having one-on-one sessions with you. We will see that you're progressing in a proper way. We will analyze you. If something is blocking you, we will tell you that this is the proper way of doing it, right? So this is what we can offer you in addition to the course that you're paying for. Okay, guys. So with this, so I'll conclude by our today's initial part of explaining you about the session. I think this answers most of the questions. I have compiled all this by taking into account of whatever questions that I was asked yesterday, right? So today, let welcome all. Welcome to this session. A very warm greetings from Mercy Technologies. So what is our agenda for today? Our agenda for today is we are trying to see what are the types of data structures, what is asymptotic notations, and how do you calculate time complexity of simple loops. These are 3 points we are going to cover today. These are very interesting, guys. Just check out with all your interest. Guys, one important thing that I want or expect from you is this is going to be an interactive and a live session. Okay, since this is going to be an interactive and live session, it's good if you have a pen and paper with you, so that whenever I ask something, you can write it down. It's not that you need to show it to me, kind of. You have intuitively come here and you are started, you start attending, right? This is early in the morning in India, and I mean, not too early, but yeah, it is a time where people get ready to their offices and etc. Students get ready to their colleges. But I see that people have come and started listening to what we are teaching, right? With this, what I say is, to bring max out of what I'm teaching, it's good if you have a pen and paper with you, so that whenever I ask something, you can write it down. You can write it down, and in that way, this becomes an interactive session. So next time when you join the session, guys, please make sure you are bringing a pen and paper, a piece of pen and paper with you. Okay. So as part of our agenda, we'll go with the first part. What are the different types of data structures? So data structures are of two types. One is physical data structure, and the second is logical data structure. Physical data structure is nothing but they exist in memory physically, right? They exist in memory physically. Okay. When I say physically, it means it has an intuitive way. For example, you take arrays. I'm speaking about the left side one. You take arrays, right? So I put the number as 5 and 6 because let me start from here. Okay. So the arrays and linked list, how are arrays stored inside the memory? They are stored inside memory next to next. They sit like as if you're sitting in a line, as if you're standing in a line. They'll be having an index, and after the index 1, there comes index 2, and there comes index 3. So in those indices, the data will be stored, and which is consecutive, right? So that is called as an array. But what about linked list? Linked list is nothing but it is a data structure that has a node, and node consists of the data and the pointer to the next node. We'll be going into the details of linked list as we move forward. But what I want to emphasize here is, there are physical data structures which are arrays and linked list, and there are logical data structures, stacks, queues, trees, and graphs. So let me give you one pointer introduction to all these. Stacks are nothing but it is a data structure that follows last in first out. Like if you have stack of plates, like in your home, let's say you arrange plates one on one, one on one, one on one. When you try to open or take one plate, you'll be taking the top plate. You'll not be taking the bottom plate, right? You'll not be taking the bottom plate. You'll be taking the top plate. Okay, so that is called as a stack data structure. Queues, like we stand in queue. Let's say we go for a movie in INOX or whatever. We go to the box office and we take tickets for access. So that is standing in a queue. That data structure is the first in first out. Whoever comes first will be given the ticket, and after that you will get out of that queue. That is called as first in first out. So trees data structure, so this is a data structure that has that has a root, and it has its children. The children in turn has its children. So this is tree data structure. Graph is a flavor of data structure. Like graph is also a tree, but based on some conditions. If graph satisfies a few conditions, then that becomes a tree. So as we move forward in our agenda, as we move forward in the course, I'll be telling you in depth on all these data structures, right? Stack, queue, tree, and graph, arrays, and linked list. Okay, so I told you that these are logical data structures, which means using some logic you can create these data structures. So using array, I can create a stack. Using array, I can create a queue. Using linked list, I can create a stack. Using linked list, I can create a queue, right? So using these physical data structures, I can create logical data structure, right? How we can maintain the trees, how we can maintain the graphs. So there are different ways and different notations. What is the best way? How to move forward? Everything you'll be knowing as we step further in the course, guys. So with this, you are I gave you an introduction of what are the data structures that we are trying to learn as part of this course, and not just learning all this theory, guys. This physical data structure, linked list and stacks. Okay, logical data structures, stacks, queues, uh, stacks, queues, trees, and graphs. Not just learning, theory out of it. So what we learn is In a stack, what are the different operations? Queue different operation, tree different operations, graphs different operations. So when you take linked list, how do you insert a linked list at start, in middle, at the end? How do you find a loop inside the linked list? How do you find the number of elements in the linked list? How do you delete linked list? If you delete, how do you delete it first? How do you delete it middle? How do you delete it last? So all these seem very simple, but there are few important points that you need to know so that you become master in writing the operations. Okay, in writing the operations. So we'll be taking care of the base conditions, we'll be taking care of all the we'll be taking care of base conditions, we'll be taking care of the null pointer exceptions, etc., etc. Just by writing the code, at the time of writing the code itself, will make sure that it impresses the interviewer, will make sure that it gives no compile time exceptions when you try to compile that, or will not give any runtime exceptions, because that is taken care in the logic, right? So this is a simple theory. So what are the real-time use cases, guys, where we use linked list? It's like we have a music player in our mobile phone. So let's say you want to go to the next songs. What you do, you click on next. So that next is nothing but is a next node. So to the particular song, let's say you have that, you think that is a node, and there is a next node which is the next song. So the first song will be pointing to the second song, right? I think you got my point. So in this way, linked list is used. This is a real-time use case, guys. Like when you try to achieve or derive an application similar to this, then you use a linked list. When do you use a stack? Like we all keep browsing things, like we browse things, like we go to YouTube, we go to Google, we go to Facebook, right? We often come back, we often have a back button inside the browser. And how is that back button implemented? Is that back button is implemented using a stack, because once we go back, we should be going into the page that we have recently opened, last opened, right? So stack is a last in first out data structure. So in that way, it opens the recently opened web page. So in that way, it is internally using a stack. So what about queue? We have job scheduling and operating systems. I'll not go deep into this, but this job scheduling is something that has a queue in it. Like using that queue, it gets a priority of the job that has been scheduled at first, and after that, it moves on kind of. And trees, we have different folders that are there in our Windows operating system or Android or iOS. Like using folder, we can have one more folder inside it, and we can have one more folder inside it, and at the end we may not have anything inside a folder. So all these folder data structures are implemented using tree data structure. Graphs, yes, we use Google Maps every day. So how do you know, like how will Google Maps know that, okay, I need to go from a point A to point B? So what is the best possible route? It uses internally graphs data structure. There are problems like traveling salesperson problem. There are problems which cannot be solved in a correct time complexity. So there are various other problems inside this graphs, but we'll go deep as we move forward in the classes. But the thing to know or note at this juncture is graph data structure. Google Maps is a real-time example. So what is a try data structure? Like as I type something in the notepad, or as I type something in the word pad, let's say there is a spelling mistake, and I made a spelling mistake last time, guys. Since I opened or written that in a notepad, it's not having, it doesn't warn me that you have written a spelling mistake. But let's say I do the same thing inside a word. So what happens? There will be a red line which will be coming, and that indicates that I made a spelling mistake. So how Word comes to know that I made a spelling mistake? It internally uses a try data structure. Try is a data structure. I remember one of my friend failed in his final round of interview. The manager asked him, uh, what do you call, what kind of a data structure do you use for this kind of things? There is a problem called edit distance problem. We'll see that as we move. So he was actually intending about the edit distance problem, but the interviewee was not able to catch that, and he was giving different answer. But he expected a try. He expected the person to use a try data structure, right? So knowing the name itself is very new to most of the people, guys. So knowing the name itself is new. But I think now, as we move forward in the course, we will be seeing the edit distance problem. So with that, what you can understand is we can use try for this particular scenarios, right? So these are some real-time already available use cases, guys, in the project as we move forward in the in our company. So let's say manager asks us to implement something. So what we do, we as part of our first step, what we do, we'll be thinking what to do, what to use. If you don't know what exactly are there, you will never be knowing how to use or what to use, kind of, right? So these are the data structures that are available, guys. With this, let me move back. We are done with the first part. We got the introduction to the data structures, what are its real-time use cases, what are some one pointer definition to all the data structures that I have asked you or showed you on screen right now. Now go to the second part of our session today. So what I'm trying to tell you here is I'm telling you about the asymptotic notation. In mathematics, I'm not going to teach deep in mathematics, but what I say is, let's say there are two curves in data structure in mathematics. Let's say one curve is f of n and the other curve is g of n, right? When f of n has a curve in respect to g of n, which means that curve is called as an asymptotic curve in mathematics, right? So we use this asymptotic notations to achieve or tell the runtime growing nature of our algorithms. So that is why they are called asymptotic notations. This is high level definition, guys, but let me not confuse you. Let me go into some details. I want to explain what exactly I'm trying to give you today. So for anything that we do, there will be three cases: best case, average case, and a worst case. So I'll give you a small example. Today, what I'm trying to do is there is some file. I want to transfer that file to my friend. My friend is residing in Delhi and I'm in Bangalore. So what I need to do, let's say it's a small file. So what I can do, I can open up my laptop, I can send it to my friend who is residing in Delhi. I can open up my Gmail, or I can use file transfer protocol FTP, and I can send it to his IP address. So this is a small one. Okay, it can be sent just like that, just like that. So I have even one more way of doing the same thing. Okay, what I have, let's say I take a flight ticket from Bangalore to Delhi, and what I want to do, my intention is to take this file from Bangalore to Delhi to my friend. Okay, what I can do, I can copy that into my pen drive, I can put that in my pocket, go to airport, take a flight, give it to that guy, and then come back. Okay, so in this analogy, guys, two things very importantly we need to learn is, in the first case, when you're trying to send the small file to your friend, you can send it just like that, I mean in no time, because electronic transfer is very easy. So what I'm trying to do, it's a 10 MB file. Let's say it's a 10 MB file and you are able to send it just like that over an email or FTP. But let's say it is a 1 TB file, 1 terabyte, or it's a 5 terabyte file. So if you want to transfer that in using file transfer protocol, even if you have the best of your internet, it takes days to transfer from here to another place, right? So with this, what we understand is, as the input size grows, the amount of time taken is also growing. So that is a growing nature. What is our algorithm? Our algorithm is to take this file from a point A to point B, but the time is getting more when the size is getting more. So the size is directly proportional to the time in our case, right? But you take the second case as an example. Okay, even if it is 1 TB file or even if it is 10 TB file, what you can do, you can have multiple hard drives, or you can have your own pen drive, you can copy that, and then you can take that file from here, taking a flight to your friend. So second approach does not have any relation with the time, right? Second approach does not have any relation with the time, because even if with the input size, even if the input size is very small, it takes the same time. Even if the input size is more, it takes the same time. I'm not thinking about the border cases, guys. I'm not saying I'll be what do you call, I need a special flight for taking this to that or nothing like that. What I want to emphasize in the second case is, irrespective of the input size, the time taken by you is the same. So the second case is called as constant time complexity, which means irrespective of the input size that you give, the time taken by you is the same. But in the first case, it is directly proportional. How it grows? The algorithm grows as you increase your input size. The growth rate can be a linear way, which is order of n. It can be an exponential, which is n square, n cube, or it can be even less, even more. But what I want to say is, in our first approach, the input size is directly proportional to the runtime complexity, right? Runtime complexity. With this, what I want, or what I wanted to tell you is, when there is constant time complexity, which means irrespective of your input, it takes the same time, then that is the best approach, guys, because that is the best approach. Whenever we try to analyze time complexities, we'll be concentrating on worst case time complexities. Like, for example, let's say best case time complexity, uh, it can be done just in order of one. Any algorithm that you take, the best case time complexity will come somewhat near order of one, because in the best possible way it can be done in this way. But what about the worst cases? We will, in computer science or in the real time, so we will be concentrating only on the worst case scenarios. These worst case scenarios are important because because we should be writing the algorithms taking worst cases into consideration. For example, let's say what I say, uh, in the worst case, a person can live up to 100 years, right? Up to 100 years. What I'm trying to say, the person may die when he's exactly born in in 1 year, 2 years. So to max, he'll be living here for 100 years. So we should make sure, while we are trying to live, we should make sure, okay, I'll be living here for 100 years, so I should make the things according to that. So in the best case, I can the person can be no more in days, but that is not what we intend. What we intend is, at the worst, he can do this. So taking that into consideration, we need to move forward, right? So let me take one more small analogy. You went to a shoe shop. You were intending to buy something. Let me write it down. Okay, your intention is to buy a pair of shoes. Okay, so you went to buy a pair of shoes, and then you bought even socks along with the pair of shoes. Okay, one of your friend has already come and he's asked, hey, why did you come to the shop? And you say, I came to buy a pair of shoes. You will not mention socks, because when compared to shoes, the socks is negligible, right? The socks is negligible. So you say, I came to buy shoes even if you bought socks. So like that, as I told you previously, any algorithm, we can represent that in form of an equation. For example, let's say I have an algorithm which f of n is equal to 3n plus 2. Okay, so there is some function like this. I've written an algorithm and it has a function. It has been derived to a function like this. What I say, when a function like this comes, the worst time complexity is order of n. The reason why I'm telling is order of n is, we are neglecting this 3 and 2. These are constant things, guys. These are constant things, and we are neglecting, and finally we are saying it's order of n. Similarly, let's say there is one more equation which says r f of n is equal to 3n square plus 2n plus 5. Okay, we have something like this, an equation something like this. We say it is order of n square. The reason why we say it is order of n square is, in comparison to this n square, this 2n plus 5 and this 3 both are negligible. similar to the analogy that I said. You are not mentioning about socks because in comparison to the price of shoe, socks is nothing, right? Similar way in our analysis also, as we move forward, we'll be deriving a few conditions or few functions like this. So after we derive, we finally say the time complexity is order of n square. The reason is n square is more in comparison to this 2n plus 5 or this 3, etc., etc. So with this, guys, this is what I wanted to say. First thing is there are things that we intentionally leave aside, and there are things we actually care about. Those things that we actually care about are the upper cases, right? Are the worst cases. I told you are the worst cases. So these are the worst cases. What happens? I'm speaking about the point number 3 in my slide. We are taking the worst cases into this consideration. When we go into the theory of this, as I told you, the asymptotic notations, what are the graphs that are present, etc., etc. So all these things will be coming into picture, but maybe I'll tell as we move forward in our course. One day I'll take session only for these graphs, guys. But at this point of time, what you need to understand is in computer science or in the real time working, we'll be taking the worst cases into considerations because there is no point of taking best cases. Okay, this is talking about best case and worst case analysis. As I told you, for any problem that we are trying to do, there is no point of analyzing the best case. For example, let's say you want to find the length of an array, and let's say the length of the array is 10. Okay, so in the worst case, what we'll do, we will travel one by one, and we'll have a variable called count, and at the end, what we say, the count is 10. And what we have to do, we have to iterate over the loop for 10 times, right? So in the best case, why do we need to do best case analysis? In the best case, let's say the array's length is 1, or let's say the array's length is 0. So there's no point of iterating itself. So this is the reason why people don't really try to analyze this best case analysis. People try to find out the worst case analysis. When you go with the worst case analysis, what happens is the best case is also covered, and in that way the algorithm that you are about to write will be robust. What is the 3-point agenda? Types of data structures we covered. Asymptotic notations. The asymptotic notations, as I told you, we are trying to analyze the worst case actually. But there are one more things. I want to explain one small thing here. There is something called average case and worst case. In theory, average case is somewhere in between best case and worst case. Okay, but in industry right now, people are tending to use this average time complexity also the worst case time complexity. For example, let's say in the previous example that I told you, I say a person can live for 100 years, right? Max of 100 years. Let's say I put it as 130 years. So this is called as theta. This is an average case. Okay, what I can say is in the worst case, he can live less than 1 lakh years also. That is also true theoretically. He will live less than 1 crore years also. That is also true theoretically. In worst case, he can live for this, and that is true also. But we really don't care about, like, we know with our past experiences that the person cannot live for more than 100 years, right? So that becomes an average case, which is theta. Okay, best cases, like, best case is something that I don't want to mention, but worst case is also the average case in most of the cases. In industry, we are not using theta, but we are using order, which is big O notation, even for the average cases. So which means you can conclude at this junction, I'm not blaming the theory, but what I want to explain here is even the theory says worst case, we are considering the worst cases which are feasible, right? Which are feasible. This is one thing I wanted to emphasize at this point. Okay, so let's move forward. One thing that I want to explain to you in today's session is how do we calculate the time and space complexities? How do we calculate the time and space complexities? Today's emphasis would be calculating the time complexity only, and that too for loops. Okay, just a second. Notations. Okay, so types of analysis is best case, average case, and worst case. Okay, Best case is the minimum time required for a program to execute. Average case is the average time required for the program to execute. Worst case is the maximum time required for the program to execute, right? So what I told is as an analogy, what I told in the best case, I mean, it's not a worst case, but uh, for example, in our session, for our session, let's take it like that. So a person can live for 100 years, right? That's an average case. That's an average case. Let's take. In the best case, he may not live for that long. In the worst case, as per the theory, what it says is a person can live for a max of 1 crore, right? As a theory, it should be less than 1 crore. Obviously, he's living for, let's say, 50, 60 years. It is less than the worst case, but it's every time it's not the correct way to take the worst case into analysis. So what happens is, in the industry, we tend to use this average case as the worst case, right? But the theory says theta notation is somewhere in between best case and worst case. But in practical, we take this average case and worst case also the same. The reason is, like, I told you that there's no point of analyzing the best case for the algorithm we are writing, because we do because if we analyze the best case, it may not be possible that our algorithm will come with the best possible outcome. So average case and worst case, average case we use, worst case we use, but even the average case, people denote that using big O notation. I never saw any person who is using a theta notation for denoting the worst cases, right? Even in the average course also, people are trying to or tend to take something which is worst, but they are denoting that using big O notation. So the industry is following that. Let's follow the same thing. This is what I was saying. Okay. So so let me come back to the time complexity. So I have different loops over here. I think you're able to see my screen now. Okay, fine. People are able to see my screen. Okay. So what I'm trying to achieve in this is, we have different for loops over here, right? So people generally ask in an interview, I'll give you a piece of code. Just tell me what is the time and space complexity of this particular code. You should be in a position to answer that. So with this, I've taken simple examples. So these are the cases, guys. Like, for example, the cases that people tend to ask in interviews is order of n, log n square, n cube, 2 power n, different things. But what I want to ask here is, we'll be having simple loops. Using these loops, we are trying to find out the space and time complexity. This is not the end of what we are trying to achieve. The reason is here in this loops, we are trying to do a best case. The iterative analysis of time complexity and space complexity. There is one more thing which is a recursive analysis. That recursive analysis we'll see as we move forward in the course. But for now, I'm trying to explain you. So first loop, I've taken a loop which is I is equal to 0, I less than 5, I plus plus. We are doing some action, and this some action is constant every time. It is the number of steps is 5 every time, and the time complexity is order of 1. The reason for denoting the time complexity is order of 1 and not order of 5 is, we are neglecting some constants. I told you, when you go to a shoe shop, you're buying shoes and socks. When your friend comes and asks, what are you buying? You say that you're buying shoes, but you neglect the socks because you feel the cost of socks is very less compared to shoes. Similarly, when you try to achieve or denote something which is constant, even if it is 1 lakh, you denote that with order of 1 time complexity. The reason is, even the case is 1 lakh, we are denoting that with order of 1, because what we try to express over here is, our algorithm is not increasing as the size increases. It's not that we are telling them this many steps it's taking. It's not that. So our algorithm is not increasing in its size as the input size increases. So this is what the first loop says for us, guys. Now let's go to the second loop, right? Let's go to the second loop. The second loop, what it says, we are trying to iterate over a loop from 0 to n, and we are doing some action. The number of steps are n, and the time complexity is order of n. It's not order of 1, and the time complexity is order of n. So why the time complexity is order of n? Let's say the input size is 100, we have 100 steps or 100 iterations. If the input size is 1000, we have 1000 iterations. If the input size is 10,000, we have 10,000 iterations. So as the input size increases, the number of the number of iterations increases, and because of that the action that we are trying to do will increase in that particular time. So since it is directly proportional to the input, it is increasing linearly in the input that we are giving. So that is why the time complexity will become order of n, and the space complexity will become order of 1, because the space is not increasing even though you are increasing the the number of steps. The extra spaces that it is occupying inside the memory, it's not increasing. So that is why the space complexity is order of 1. Now let's go to the third loop. What is the third loop? Why is it significant? So it has two loops, the first loop and the second loop. The first loop has an outrage, or it is covering the second loop, which means, let's say the input size is 2. What am I trying to do? The first loop runs for first time and the second loop runs for 2 times, right? And again the first loop runs another time, second loop runs for twice. So which means it is running 2 times, and it is running 2 times, which is 2 into 2, which is 4 times. It's running 4 times. You take the same example for 3, take the same example for 4. What you understand is the number of steps increases in an exponential way. So it increases in the n square manner. So what happens? The number of steps are n square. So that is why the time complexity will become order of n square, because the algorithm is increasing in the order of n power 2 for every input n that we are giving, right? But the space complexity is only order of 1. The reason is, even though you have 2 loops or even though you have 3 loops, the space complexity is order of 1, because you are not consuming extra memory inside your, by using this program, you're not consuming extra memory. So that is why you're not increasing memory. So that is why the order of time complexity is 1, right? So let's say we have one more loop over here. We have one more internal loop, I is equal to uh, int k is equal to 0, k less than n, k plus plus. What happens? The number of steps would be n power 3 and the size space complexity will be n power 3, right? Let's go to the next loop. What is this loop saying? There are two loops over here and one loop is independent of each other. So what happens? Let's say the input size is 2. This runs for 2 times and this runs for 2 times, which is total of 4 times. Let's say the input size is 3. This runs for 3 times, this runs for 3 times, which is 6, which means n plus n, which is 2n. So which means the number of steps are n plus n, which is 2n, which is 2n. So but as per our analogy, what we have done, we are ignoring some things which are constant. We are ignoring 2 over here. That is why the order of time complexity will become order of n. It's not order of 2n. We are ignoring 2 here. Okay, even if it is having 10 loops, we'll be having the time complexity as order of n only. It's not 10n, because we are ignoring 10 in that case. The space complexity will be order of 1. The reason is we are not consuming extra space over here. Now we are going to the next loop. What I'm doing here, I'm taking I is equal to 0, I less than n, I is equal to I plus 2, I plus 2. So this loop is incrementing 2 times for every action that I do. So let's say the input size is 10, the number of steps would become only 5. Input size is 20, the number of steps would only become 10. So it means the number of steps is n by 2, but what we are doing, we are ignoring the constants. So the time complexity will not be order of n by 2, but it is order of n, because we are ignoring constant, right? We are ignoring constant. Now let's say we are trying to go to the next loop. The next loop, what it says here, it is in the previous loop it is I is equal to I plus 2. In the next loop it is I is equal to I star 2, which means we are incrementing the value by 2 times the multiplication factor for every input we are giving. So which is for example, let's say the input size is n. If we try to see, if we try to calculate by taking small examples, what we try to understand is the number of steps would be reduced by a logarithmic factor of n, right? So which means the time complexity will become order of log n. The reason is you try to calculate the number of steps by taking sample inputs, guys. After you take the sample inputs, you will understand that the time complexity, the number of steps become order of log n, and the time complexity will become order of log n. The space complexity is order of 1 as always. The reason is we are not consuming extra space. Now we are coming to the other loop. So this loop is just the opposite of the previous loop, guys. Here what we are trying to do, we are trying to start from I is equal to 1 and we are incrementing I is equal to I star 2. But in this loop we are starting with I is equal to n and we are reducing the size of n by the factor of 2.
So even here, the number of steps will become log n, and that is why the time complexity will become order of log n, right? Order of log n. So let's come to the final loop for today. What I'm doing, I'm taking an input array. The input array, I'm using Java here. The input array, its size will be incremented. Like we're not specifying any size. Let's say the size is 0. There's no size. I mean, there's nothing inside the input array. So what I'm trying to do, I have written a method called sum of input, and input would be the number of iterations that I'm trying to do over here. And what happens here, for I is equal to 0, I less than input dot length I plus plus. What I'm trying to do here, as the input increases, the size of the array increases. Size of the array increases, which means the input is 1000, which means my array size is 1000. If the input is 10,000, my array size is 10,000, which means it is consuming that much amount of memory. So as our input size increases, the space consumed inside the memory is also increasing. That is why the space complexity will become order of n, and the time complexity will become order of 1, because if you observe, there is only one loop inside. So as this is relation to the first loop, right? This is relation to the first loop. We concluded for the one loop, our time complexity will be order of n. So similarly, the time complexity for this loop will be order of n. The only speciality is the space complexity is order of n. The reason is the array size is increasing inside the memory on terms of the input that we are giving. And what is the number of steps we are doing? We are doing the number of steps as n only, because the for loop is only iterating for n times. So with this, guys, I'm trying to conclude what and how do we calculate time and space complexities in terms of iterative approaches. All these are iterative approaches. So in the sessions that we move forward, I'll be giving you a few formulae. So using that formulae, you can easily calculate the time and space complexity, and you can make the analysis of your code even in a better fashion. Guys, I think you followed me. Just reply me if you're able to understand what I'm teaching, what I've taught you till now. This is my WhatsApp number. Can you explain more about space complexity? I'll be doing as we move forward in the session, for sure. This is not the only end. I'll be giving you a special formula to calculate the time and space complexity. This is an you can feel we are halfway done, guys. The other half is pending, and it will be used for calculating bit more special cases. Okay, I'll be explaining log maybe tomorrow. Today the time is increasing. I'll be explaining you how we came to log. So before coming to the class, you can explore yourself. It's not that hard to understand, but yes, as I told you, take examples, and by taking examples, you can conclude. But tomorrow, I will explain you how we came to this logarithmic time complexity.